In this video, we are going to take a look at Visual Studio, the Microsoft IDE, the Integrated Development Environment. I'm going to talk about some of the different historical versions of Visual Studio over the years and the different versions of it that are available today. I'm going to create our first Visual Studio project. I'm going to look at what all of the various buttons in Visual Studio do. And we're going to look at all of the parts of the simplest possible C# program. So Visual Studio started about 20 years ago now. We're on the 14th version. Now that's a little bit misleading because it started at version 4. There was a previous debugging project at Microsoft that got up to version 3, so that did make some sense. And they skipped version 13, both because of fear of the number 13 and also because it did not match quite right with the year. Visual Studio 2013 is the most recently fully supported version as of the shooting of this video. Visual Studio 2015 is in CTP 5. That's Community Technology Preview 5 is the one I have running on this machine. Preview 6 shipped 2 days ago. I haven't had a chance to install it yet, so we're going to use 5. But it should look almost exactly what Visual Studio 2015 will look like when it finally ships, which my spies on the Visual Studio team tell me should be sometime in 2015. Now, there are a lot of different versions of Visual Studio, not just historically, but there are what Microsoft calls the SKUs, the stock keeping units. And they're called the Express, the Community, Professional, Enterprise, Ultimate. I think there are a couple more in there that I'm missing. And the difference between them is they all have different feature sets, and they all have different prices. The Express Edition is free, which is very attractive. The Express Edition for Visual Studio 2013 and all of the Express Editions before it came in different flavors. So there was the C# Express Edition, and there was the Visual Basic Express Edition. And there was an Express Edition just for people who wanted to write software for Microsoft phones. For the Visual Studio 2015 Express Edition, it's not going to be tied to any particular language. There's going to be just one Express Edition that will be free. You can download it, install it on your machine, make sure to budget some time, takes a while. And then you can use it to build whatever kind of software you want. And the difference between it and the versions that you pay for are there are more advanced tools in the versions that you pay for. The versions that you pay for have performance profilers and more advanced analysis tools that you might not need if you're just a home hobbyist or if you're doing relatively simple work. All right, so without any further ado, let's just actually start up Visual Studio. I've got a Visual Studio icon on my desktop here. It says Ultimate 2015 CTP, Community Technology Preview. You can see that on the screen, it starts with a news feed that tells you about what's exciting and new in the world of Visual Studio. But the interesting bit that we want is there's on the left-hand side, there's a Start, New Project, Open Project. And there's also recently opened projects here. If I had any, they would appear there. So we'll just say New Project. Now we get this super complicated dialog that, first of all, on the left-hand panel, it's organized by language, right? So there's Visual C#. Visual C# is the marketing name that Microsoft uses for C#. Nobody actually calls it Visual C#. People do call Visual Basic, C++, F#, and so on. So all of the different languages that this version of Visual Studio supports. Then within each of those languages, all different kinds of projects that you can create. So we'll go down to Windows Desktop. And again, there are a dozen different kinds of Windows Desktop project you can create. We're going to create a console application. Console applications are completely retro. Hardly anybody makes console applications anymore. But the nice thing about console applications is they are very straightforward for the beginner programmer. Right? There's just a console. You write text out to it. You read text in from it. Very straightforward. You don't have to worry about creating forms and buttons and events and controls and all of that stuff. Right? We'll start it off pretty simple. So we'll say console application. It's given us a name automatically, console application 1. So we'll just hit OK. And so then we get this little piece of C# generated for us automatically. So let me go through what each of these parts does. You can see we start with a bunch of using directives, right? These are grayed out. I'll explain why in a minute. Then we have a namespace. The namespace contains a class. The class contains this method, which is called main. So let's talk about each of those pieces in turn. Let's start with the namespace. What is a namespace? A namespace has two kind of main purposes. Primarily, it's a container for organizing your code. Secondarily, it's for preventing name collisions. So let me expand on both of those a little bit. You think about a namespace as being associated with an organization, right? Like Microsoft is the name of a namespace, or a large project, right, or piece of functionality. So Windows is another top-level namespace. The most commonly used namespace is system, which is the namespace that we have for everything that you would typically need in in almost every kind of C# program goes into the system namespace. And the namespaces are specialized further by separating the parts of a namespace with a dot. So system.diagnostics is the portion of the system namespace that is entirely concerned with diagnostic code. So that's the primary reason for namespaces, is to organize your code, because there's a lot of code out there in the world, and you got to have some kind of structure to understand it. The second reason for namespaces is they allow different organizations to produce chunks of code that have the same name without producing name collisions. So you might think that maybe a publishing company who's writing some software has a piece of code that they want to call page, that is talking about a particular page of a particular book. And you might think that another company might be writing some web pages, and they might have a bit of code that's also called page. And now what happens if you try to use these two pieces of code in the same program? They're both called page. They do completely different things. How are you going to tell them apart? And the way you tell them apart is with namespaces. Those two different pieces of code would be in two different namespaces. And now C# does not require the use of namespaces in your code, and so we are mostly going to ignore them. We're mostly going to be working on tiny little programs that are not so complicated that you would need to divide their functionality up into many different namespaces. We are, however, going to use a bunch of the different namespaces that are provided by Microsoft. So I want to talk a little bit about that using directive that we saw at the top of the program. A using directive has the syntax using, and then the name of a namespace, and then a semicolon. And the idea of a using directive is it informs the compiler that we are going to be using some of the code that is in this namespace, and that we do not want to type the namespace name every time. And so let me give you a quick example of that. We will got our project here, right? And I could say, suppose I want to write something out to the console. I could type console.writeLine. We'll talk about this in more detail in a minute. Console is a piece of code that is in the system namespace. I could also say system.console.writeLine, and that would be just fine. But because we have this using system up here, I don't actually need to type system.console.writeLine. Now, you probably noticed that a bunch of these are grayed out. When I removed the system dot from that console.writeLine, the gray disappeared from this thing. It became normally colored. What's up with that is this is a little hint to you. Visual Studio is telling you, you said you were intending on using system collections generic. You never did. You don't need to have this using directive. You could remove it. It's not wrong to be there. You might want to use it in the future. There might be a good reason why it's there. And in fact, Visual Studio put it there for you on the expectation that you were likely to use it. But it's not actually necessary. So this is just a subtle little hint that maybe you could get rid of one of these. Let me talk about what these different using directives are for. They're all in the system top-level namespace. The top-level system namespace is all of the things that are so general that there is no more specific namespace they should be in. Right? System collections generic, just what you would expect. This is code that involves collections of things. So lists, for example, right, are in the generic collections namespace. LINQ is an acronym that stands for Language Integrated Query. This was a feature we added to C#3, which is a bunch of features that allow you to sort and filter and group together elements of different collections, right? So you could say, I have a collection of customers. I would like to order them by last name, and I would like to select the addresses of all the customers who live in London. We are not going to get to cover LINQ in this course, but it's very commonly used, so Visual Studio automatically includes the namespace. System.txt is for lots of different text manipulation pieces of code. And system threading tasks is for some advanced scenarios involving creating pieces of code that run certain tasks on your behalf and do so in an asynchronous manner. So you might think of, for example, I need to fetch some information from a web service that is in Japan, or I need to write a file out to this disk, and I'm going to be writing it over the network. It's going to be slow. I would like to do this task in the background. And again, this is an advanced feature. We're not going to be talking about it in this course. All right. So that's namespaces. Now let's talk about this class here. So like a namespace, a class is also a container for organizing code. Classes organize your code by the concept in the business domain that they represent. So whereas a namespace is something like Microsoft, right? It's a large organization, or system diagnostics, right? A large sort of general subject area. Classes tend to be things that are actually nouns in whatever the business domain of your program is. So if you're writing a program that manipulates some email, then you might have a class called email address. If you are writing a game, then you might have classes like wizard or warrior or weapon. If you are writing something like the generic collections namespace, a list is something that might go into that namespace, right? That would be a class. Design and implementation of classes is pretty complicated, and it is the primary concern of a style of programming called object-oriented programming. I mentioned in an earlier video that C# was designed to be an object-oriented programming language. We're going to talk very little about object-oriented programming in this course. All right, so let's go back to Visual Studio here. And we can see that inside the class, which our class is called program, and in this course, every class that we make is going to be called program, just about. This is very straightforward procedural programming that we're doing here. In C#, every console application has a method called main. So this static void main, I will describe in a later video what the static and the void mean, and what the string and then these brackets and args mean. We'll discuss all that later. Then the method has a method body, and this is the method body. So a method is also a way of organizing code. So you see we had classes inside namespaces. We have methods inside classes. Methods are the verbs of your program, right? So if you have a noun like wizard, then you might have a verb like cast spell, right? Or move north, or whatever it is in the domain that you are writing your program about. There are verbs, and they are associated with those nouns. Methods are the things that actually do something in your program, right? And as I mentioned, every C# console program has a method called main, and it is the one that runs when your program starts. Let's make this program actually do something. Now, you probably saw before when I typed console and hit dot, we got this drop down here, right? And this is a feature called IntelliSense. The IDE is trying to figure out what are the things that you are likely to type next, right? So it knows that console, right, which is a class, has a method called WriteLine. And if I hit the open paren here, it will tell me there are 19 different versions of WriteLine. And we will look at what some of the different versions are in a later video in this course. But for now, I'm just going to say hello world with an exclamation mark in quotation marks. I'm going to put a semicolon at the end. And now we're going to actually run this program and see what it does, right? So I could just hit start up here, right? You see there's a bunch of buttons. Before we start, I'll just go quickly through what the buttons are. These ones navigate back and forth through the code files. You think about when you're on a web browser, you might want to go back to a page that you'd seen previously. These buttons let you do that. These are buttons for loading and saving and creating new projects. Nothing too fancy there. Undo and redo buttons so that you can undo the last changes that you made, redo them. This debug, there are two different ways that you can create your programs. You can create them as either debug versions or as release versions. The idea is that the debug version will have additional gear in it that makes it easier to find problems and modify the code. For the purposes of this course, we're always going to be compiling things in debug mode. The AnyCPU, there's a way to make the compiler translate code in a way that is compatible directly with, say, a phone operating system, right? So we might want to choose a very specific CPU then. For our purposes, we are not ever going to touch this. And starts the program. So let's actually hit start and see what happens. Also, fun fact, the F5 key is a synonym for start. So I'll just hit F5. You can see down there the program builds, the compiler builds, and we're done. Apparently, it ran the program and it finished before we could even see what it did. So instead of hitting F5 to start the program, I'm going to hit F10. F10 steps in. All right, so let's take a look at what we've got here. Execution of the program has stopped even as it has just begun. Right? We have this yellow highlight here that indicates what is going to happen next. And this is not what has already happened, but what is going to happen next. Right? So we have a yellow highlight. The next thing that's going to happen is we are going to execute any code that is associated with this brace. And there's no action associated with that brace. We also have a yellow arrow pointing here saying this is the point at which code is going to execute. If I hit F10 again, then now we step on down to the console.writeLine. Again, this is what's going to happen next. Right? If I hit F10, the console.writeLine has happened. So if we look at the console window, we can see that, sure enough, we have written hello world out to the console. All right, and then if we keep on executing here, then we're done. The program has finished. So what are some of the other things that we can do while we are debugging through this program? Right? Well, we saw that if we just hit F5, right, then it just went. And if we hit F10, then we step through one line at a time. A very handy feature is called a breakpoint. And this is the ability to say, I want you to go until you hit this point. Right? So for example, we could put a breakpoint right here. Right? I just went over to the gutter here, and then I clicked in this gray gutter area, and that produced a red dot, right, and a red highlight around this brace. I could also point to the brace with the mouse and hit F9. F9 turns breakpoints on and off. And now if I hit F5, or I press go, or start up here, right, then it will run the program until it hits this breakpoint, at which point it will stop. Right? So now we have both the yellow highlight indicating the next thing that's going to happen is we're going to leave the program through this closing brace. And we have a breakpoint here. Right? And if we look at the console window again, you can see we've stopped just after this line, before this line. Right? If we were to put the breakpoint up here and restart the application, we can hit stop right here, and then start it again. Then now our console window would be blank, right, because we have not executed this line yet. And if I hit F5 again to start it running, then it immediately stops on the next breakpoint. So breakpoint's very handy. Really good technique for debugging, is to put breakpoints where you think that there might be something wrong with the code, or you want to inspect it a little bit. So suppose I have a breakpoint on this console.writeLine here. I hit go. Right? Now what is going to happen if I try to enter code right now? The program is running. I could say console.writeLine. Goodbye. Put a semicolon at the end. What's going to happen next? Well, turns out that I can hit F10, step to the next line, executes it no problem, writes it out to the console, and we're done. So C# will sometimes allow you to edit code while the code is actually running. Now, it does not always do so. Sometimes you'll make an edit, and the compiler will say, that edit was too complicated. It changed too much stuff. I'm not going to allow you to do that while the code is actually running. And I recommend against trying to change the code while it's actually running. You can get into situations that are very confusing indeed. I recommend that if you're going to make changes to the code, that you always stop it if you're debugging it, make the change, start the program up over again, use breakpoints to get back to the point you were at. One other thing that I want to talk about here is there are comments. So if I type 2 forward slashes, then I can type anything I want. And it doesn't matter whether it's legal C# or not. This is completely ignored by C#. Anything to the right of the 2 slashes is completely ignored. And this allows you to add little bits of documentation to your program. If there are things that are unclear, or you just want to have some commentary over what the program does, you can use this comment syntax. There is a second syntax that allows you to put comments into the middle of things. Right? So between this right line and this parenthesis, for example, I could type slash. If I type 2 slashes, then the rest of the line becomes a comment. But if I type slash star, then I can put a comment here. And then star slash. All right, so anything between the slash star and the star slash is then treated as a comment. And these, in fact, can span multiple lines. Right? So everything, including the blank lines, becomes a comment. And this also illustrates that in C#, programs can be quite free form. Right? You probably saw that there's indentation here. The namespace is the class that's inside the namespace is indented. The method that's inside the class is indented. All of this is just to make the program easier to read. C# actually does not require it. We could change the indentation of this entire program, and everything would continue to work just fine. It'd still be a perfectly legal program. Summing up. As we've seen, the principle that a one-line program should be 1 line long is clearly not followed in C#. Right? We've had a program here that was only 1 or 2 lines long. Console.writeLine hello world, console.writeLine goodbye. You'd think that would be 2 lines long, but we had using blocks and namespaces and classes and methods. Why all of this stuff? And the answer is, as I said in the previous video, C# was designed for expert line-of-business programmers who were going to be working in large teams on large software. So the whole thing is designed towards managing complexity. Right? And that sometimes means that small things that are not very complex sometimes end up being more complex than they really should. Namespaces, classes, methods are all containers for organizing your code. Namespaces organize your code at the sort of organizational level or across broad areas of functionality, like diagnostics or collections. Classes are the nouns of your program, and methods are the verbs. And then you can use IntelliSense, and you can use the debugger to understand your code, to step through it, to tell you what things the IDE expects you're going to type next.